guys. So last couple of days we've been working with transformations. Today what we're going to be working with is we're going to be working with translations, right? And so when working with translations, the first thing we need to know is what's another way to think about a translation? And when we think of a translation, another way to think of it is a slide, right? It's literally having a figure where you don't flip it, you don't turn it. Where if we have two triangles, right? Literally, it's not flipping, it's not turning, you are just sliding it around, right? And so if this was, let's say, A, and this one was A prime, you know, if this one came last, right? Then all the translation is, it's just seeing that this went to the left, and then it went down, right? Just wanted to show you, literally sliding it around so it gets to where it needs to go. And that's just an idea. Again, we've gone over the translations, what they actually look like. I just want to show you again. Always remember, first one is called the pre-image, the last one's always called the image. The image, the last one is always the one that has the prime on it, right? And so in order for today's lesson, we need to understand an actual coordinate plane. We need to understand the components of a graph. So you have a graph, right? We always know that on this graph, there's X and Y, right? Where this axis is the X, this axis is always the Y, right? But what we need for today's lesson is to understand more about that. So we know that when we go to the right, that's positive X, right? When we go to the left, that's negative X, right? Because again, right is always positive X, left is always negative X. When you go up, that's always positive Y. And when you go down, that's always negative Y. Again, you guys have learned this a long time ago, and you've seen it a lot of times, but this is the most important thing of today's lesson, because knowing these directions, it tells you everything you need to know about how to deal with the translation. When you go to the right, you're gonna add to X, right? When you go up, you're gonna add to Y. If it says you're going down, you're gonna subtract from Y. If you're going to the left, you're gonna subtract from X, right? And that's the main idea of this whole lesson for today. It's just knowing that idea. Exactly that. Always having these directions in mind, and always keep in mind, again, if it says you're going left and up, well then we know, since we're going left, you're going to subtract from X, right? And then since you're going up, you're gonna add to Y. And it's this whole idea that you'll start seeing how to apply all this, right? Again, when we're dealing with translations, it's always trying to figure out where is it going to end up, right? What are the coordinates going to be? So in order to figure that out, let's just play with it, right? Let's say that we have a pre-image. Let's say we have a pre-image that is, let's call it F, and let's say that it's 2 and 5, right? And now I'm going to tell you that it's translated. 8 units right? 8 units right. And it's getting translated 4 units down, right? So we know that. We have that pre-image. We know it's getting translated 8 to the right and 4 down. What I want to figure out now is I want to figure out what F prime is going to be, right? I want to figure out what the image is going to be if that's where we start. And now the way you got to think of it, always identify them because it does help, right? We know that this is our X. We know that the last one is always our Y. Always. First one's always X, last one's always Y, right? It's telling you right here, you're going 8 to the right. When you go to the right, that's X, right? And when you go to the right, it means you add to X. When you go to the right, you add to X. So since we're going 8 to the right, you're going to add 8 to our X, right? And the reason we're adding 8 to our X is, again, right has to do with X. And since we're going to the right, that's positive, right? If we're going 4 down, again, down has to do with the Y. Since you're going down, you're going to subtract 4. And the reason you're subtracting 4 is whenever you go down, down means minus Y, right? When you go 8 to the right, it means you're going to add to the X. When you go 4 down, you subtract from the y, right? And now once we have that, it's just figuring it out, right? 2 plus 8 is 10. And we know that 5 minus 4 is 1. There's our answer. It's that simple, guys. It's just analyzing and applying that idea from before, knowing all the directions and all that, right? Yeah, let's try another one just so you guys actually see it, right? See if you can actually get a good understanding of it. I'll get rid of all that. So let's say now, again, I'll give you another coordinate. Let's say that the coordinate that we have now, let's call it D, right? And let's say that it's -3 and it's 8. And I'm going to tell you that we're going to translate for, let's say, 7 units left. And then let's say that we're going 3 units up, right? Okay, we want to figure out D prime. We want to figure out what D prime is going to be. So knowing that, same idea that we did before, let's identify what our x and y is. We know that the -3 is our x. We know that the 8 is our y, right? If we're going 7 left, again, when we go left, that's our x. And if you go left, you're going to subtract from x, right? So we're going to subtract 7 because since you're going 7 left, left means you subtract from x, And so we're going 7 left, so we do -7. Then we're going 3 up. When you go up, that's a positive y, right? And since we're going 3 up, you're going to add 3. And we're going to add 3 there because since we're going up, up means you add to y, right? So now once we have that, we just do the math. -3 minus 7 gives us -10. Because if you owe me $3 and then you owe me another 7, you're going to owe me 10. And then if we have 8 plus 3 gives us 11. It's that concept, guys. It's that idea, right? And there are always different ways of also being able to see this too, right? Sometimes they'll explain what's going on. Other times they'll actually write it out with the formula. And that formula is what we're going to be working with. I do want you guys to get in the hang of seeing it just because it's so much easier to actually work with and see, right? So again, let's give you a coordinate. Let's say that we have A where we have 4 and we have 9. And I'm going to tell you that it's translated by this rule where we have x, y goes to, we're going to go over this in a minute, x, y goes to, let's say we have x minus 2 and we have y minus 8, right? And again, even just looking at this, let's say we want to find 8 prime. Even just looking at this, you start to get the hang of what's going on, right? Since it's x minus 2, x minus means you're going to the left 2 because x is negative, right? And then it also means you're going down 8 because since it's y minus means you're going down, right? When it's x plus, it means you're going to the right. When it's y plus, it means you're going up. But again, we'll get to that in a second. So now having all this, right? It's telling us that we have that coordinate. Again, that's our x, that's our y, right? And it's telling us literally that the translation is represented by this. And all you would do, it's literally as simple as what it's saying. It's saying to take x, subtract 2. It's saying to take y, subtract 8. So we know that x is 4, so we're going to do 4 minus 2, right? We know that y is 9, so we're going to do 9 minus 8, right? We know 4 minus 2 is 2. We know that 9 minus 8 is 1. Here's our answer. It's that simple, guys, especially when it comes to this. Sometimes it looks more complicated, but sometimes what looks more complicated is to make our lives easier, a lot easier. You don't even have to think. Still tells us our directions in translation, but it's just a nice way to look at it all more cohesively. So now getting to this, right, this rule here, it's this rule that's actually very important because it does tell us everything that we need to always see. And it does pack everything nicely so it's not all over the place or having to write so much out. But what that rule is called, it's something that's called coordinate notation. Coordinate notation. And what that coordinate notation is used for, again, it's used to represent a translation without always having to write out all the words, right? The signs and the x's and the y's tell us everything. So let's say we have, again, x, y goes to. Every time you see that, it literally stands for the word goes to, right? Goes to. Now let's say now that I gave you this, x plus 5, y minus 3. I wanted to analyze that and what that means, right? If it's saying x plus, if you have x plus, it means that x is positive, right? What direction is x positive? When you go to the right, right? And since it's saying x plus 5, it's telling us that we're going 5 right, right? And now look at the other one. It's saying y minus 3, right? When is y negative? The only time y is negative is when you go down, right? So we know we're going down. Since it's y minus 3, we're going down 3. So all this tells us that we're going 5 to the right because x is positive, and we know we're going 3 down because y is negative. That's the importance of that coordinate notation. It tells us everything that we need to always know, right? It tells us everything we need to see. And what's good about that is, again, it helps us be able to represent our translations. Sometimes they tell us, sometimes it's easier for us to actually write them out ourselves, right? So if I wanted to translate 6 units left and 1 up. Say I wanted to do 6 left and 1 up. What would be the coordinate notation? You always start with the first part, which is x, y, goes to, because all that means is any coordinate is going to go here, right? Any coordinate is going to go there. And since, again, always x comes first, since we're going 6 left means it's x minus, right? 6. Because since we go left, that's our x, right? And when it's left, it goes minus. The other part, 1 up, means it's going to be y. Since you're going up, that's a positive 1. It's that idea, guys. It's just that simple when it comes to looking at coordinate notation. It's analyzing what direction and then what it applies to. If you go 6 left has to do with x. When you go up, that has to do with y. Just don't always go in the order of the wording, guys. Always go in the order of what it's telling you, okay? So that's coordinate notation. And then we have something else that's called component form, which again, all these things seem complicated, but they're actually all very, very simple. And what component form is, it's just another way to express things that makes it look even easier, right? If you were to ever see something that looks like this, where you have an 8 and you have a -2, again, these aren't parentheses, but again, component form is usually used to represent translations, right? So whenever you're seeing component form, it's used to represent translations. It tells us everything that's going on, right? The first ones always are x, right? First one represents our x. The second one always represents our y, right? But it's not a coordinate because, again, these aren't parentheses. What this is telling us is our translation, right? So we look at it. Since the 8 is positive, and that's our x, when is x positive? So x is positive when it goes to the right, right? So it's going 8 to the right. And then think, when is the y negative? When the y is negative, it means you're going down. You're going 2 down. That's all it is, guys. Whenever you see component form, now it even gets rid of the variables. It just gives you pure numbers, whether it's positive or negative. If the x is positive, it means it's going to the right. If the y is negative, it means it's going down, right? If I were to get rid of this, again, if x is positive, it goes right. But now if the 2 is positive, it would go up. It wouldn't go down anymore, right? It's just having that idea, guys, of looking at what the signs are. If that 2 is positive, now it goes up. Let's say that this 8 was negative now. If x is negative now, instead of going right, now you're actually going left. It all goes back to that graph that I drew you guys at the beginning of class, right? Always remember, component form, it's just the numbers, guys. Whether it's positive or negative, it's what tells us everything. And then the last thing I want to show you is an example of how you actually use component form to figure out an image, right? So let's say again, we know that the image, let's say that the pre-image is, let's say we have a pre-image, let's call it K, and we know that K is going to be -3, 7, right? And I'm going to tell you that the component form, the translation, is going to end up being, let's do it as 6, and then let's do it as -4, right? There you go. Sometimes without thinking too, remember, it's not a parenthesis, guys. It's not parentheses, it's actually a little arrow at the ends to show you. Those are translations, right? We want to figure out what K prime is going to be, right? We want to know what K prime is going to be. So again, always think, if it helps you, label everything, right? This is our X, that's our Y, right? We know the same thing. This represents our X, that's our Y, they go together, right? And now all it is, it's telling you to do. We know that the 6 is positive. Since the 6 is positive, X and X, 6 is positive, you're going to add 6, right? Over here, the Y and the Y. Since the Y is negative, you're going to subtract 4. So now we know -3 plus 6 gives us a positive 3. Because if I owe $3 and I just got 6, I ended up paying back the 3, and now I have 3 extra ones. And then we know 7 minus 4 gives us 3. There's our answer, guys. Just always remember, component form, coordinate notation, they're all ways to represent translations, guys. Hope this helped. Take care.